So today we are going to talk about matter, then water cycle and changes of state. So over the years, right, what are the questions that came out? All right, so take a look. There are 7 questions. How come this one is suddenly changed to the O become A? Okay, ignore that, okay? Anyway, I want you to take note. What is the meaning of melting? What is the meaning of freezing? What's the meaning of boiling? Then evaporation, condensation. Boiling and evaporation is also very, very commonly asked. Okay, sometimes they ask in the MCQ, sometimes they ask in the open-ended. So last year, even there was a question. They asked what is boiling. Okay, so you're supposed to write down definition. So if you need this, don't worry. Don't have to go and copy down. You don't panic. I can send it to you later. And you can download the slides. Okay, you can download the lesson notes. Raha, you managed to download the notes, right? Last week? Yeah, I told the tech team quickly upload it because my student Raha wants to have it. Or your parents want you to copy. Okay, I give you a short time to copy. Okay, or what I can do is, let's see. Let me see whether this works. All right. Can it in the chat? Are you able to see in the chat? I took a screenshot and then I put it in the chat. Can see or not? You quickly download it. Celestine, can see that? Good. So I can move on, right? So anytime you all need anything, let me try to take a screenshot for you. Then I send to everybody. Okay, good. Now, what is the difference between boiling and evaporation? Take note, boiling and evaporation, crucial. Okay, I pause first. I want y'all to actually save the earlier screenshot I have just sent to you 1 minute ago. I give you time. Otherwise, y'all will panic. Okay, go and take a screenshot. Click on that picture I sent. Save it into your desktop. Yes, thank you, Giselle. Giselle is quite good with computers also, right? Yeah, good job there. So this one as well, boiling. There's a very big difference between boiling and evaporation. Evaporation is only taking place at the surface of the liquid, and it only will happen right at the top layer. It happens at all temperatures below the boiling point. Okay, below the boiling point. Now, boiling happens throughout the liquid. If you boil water, how many of you have seen water boiling before? Some people have those kettles, right, that are made of glass. Binuli did, huh? Or you all try to cook Maggi mee, you boil some water over the stove, right? Do you see that when the bubbles first appear, it appears at the bottom? Yes or not? It appears at the bottom, right? Yeah, why? Because at the bottom, okay, that is the place where the water gets the external heat source. Okay, so the heat is obtained from the bottom. You have the fire at the bottom. If it's the kettle, it is the heating element, which is at the bottom. So water at the bottom gets all the heat first, then they start to boil first. Okay, and then in secondary school, you're going to learn some convection current. I'm not going to talk about this now. It's very interesting. Yeah. Take note, boiling only takes place at the boiling point. Okay, Joanna asked me, are you talking about the evaporation? Just below boiling point, or can it be below the boiling point above the freezing point? Yes, you can say that. But even ice, right? Okay, ice also can vaporize. If I use the term vaporize, means it changed into vapor inside the freezer. Have you all observed that? You look at your ice tray. I think in my class, you all have heard it already. You look at the ice tray if you don't use the ice that you have actually made, soon enough, okay, you're going to see that the ice became smaller. Right on. And it's not like such a big piece you usually have inside your dream. Right now, Joanna, do you see that the eyes actually become smaller? So this is additional knowledge for y'all, but it won't be tested. Difference, yellow, seeing, did you answer properly? Even this paper here, you have one question. So you see, they usually ask you to state one difference. Okay, there are two differences here. You see, boiling happens to all of the liquid at once. Okay, so happens to all the liquid. We can also rewrite this as throughout the liquid. So it is not just at the top layer. It is the whole thing. When you see boiling, okay, happening to the kettle or the pot of water, there's a lot of bubbles, right? Very violent kind of bubbling going on. And you can hear a lot of sound, right? Because it is happening throughout the entire liquid. You will see so many bubbles, so violent. Very good, see, you got the 1 mark, huh? So you can say boiling happens throughout the liquid at once and occurs only when the liquid is heated to one specific temperature, which is the boiling point. So evaporation can happen at any temperature below boiling point. Do you need to mention freezing point? Usually no. Okay. They don't even go to that extent. So you can talk about any temperature below the boiling point of the liquid. Why freezing point don't need? Because freezing point, you already get solid ice, right? We are talking about the liquid. What? The liquid is in liquid state. Okay, so evaporation is liquid to gas. So no need to mention the freezing point. Freezing point, you already get solid of that substance. Okay, so it can happen only to this at the surface. So one point you can write down is the difference between them. Okay, boiling takes place at boiling point. Whereas evaporation takes place at any temperature below boiling point. That's one. So what's the second point? The second point will be one takes place throughout the entire liquid. The other one takes place only at the surface. Is it okay? So that is point number 2. Pranush is here. Hold on. Let me allow him in. Okay, so second point over here. Boiling takes place throughout the liquid. Whereas evaporation, Shen Shen is here, 1 minute. Let Shen Shen come in. Okay. Takes place at the surface. Now, how you write this is also important. Okay. You are supposed to write down boiling takes place throughout the liquid, whereas evaporation takes place only at the surface. Do not write down boiling takes place throughout the liquid, but evaporation does not. Clear or not? Don't always use the bad habit of but something does not. They don't give marks that way. Clear? They never give marks that way. Even for primary 3, initially, your teacher will mark okay, right? They'll mark you correct because they want to encourage you to love science. But if you continue writing that way, P4, your teacher will tell you you're not getting the marks anymore. Okay, but if you go on to P5, writing like this, and then you drag on to P6, and you don't force yourself to change, then you're going to lose the marks in PSLE, you know, and you are not getting your papers back to check your answers. Agree? When you don't see your own answers, right, you don't know where you have gone wrong, etc. So make sure you write down the best possible answers to score the highest marks. Is it okay, people? Okay, make sure you're writing in such a way that you will score the highest marks. Okay, so don't ever try writing whereas or but the other one does not. Don't write that. Okay, so this part here, can I go on now? Do you all need the screenshot or you are okay? If you want a screenshot, let me just quickly take it for you. Right, and now I'll send in the chat. Yeah, lor. I also Celestine is suddenly changed to that. My other slides are okay, you know. This morning I was typing these notes for you all, right? Prepare the notes for you all. It became like that. Give me a shock also. You see, this one is okay, right? Yeah, so it actually made me a bit surprised as well. Later, I'll get the tech team to help me check on the slides. Okay, let's see this question now. All right. Okay, there was a question earlier. Yeah, that's not right, right, PE? Yeah, lor, I will ask them to check what happened. Okay, you see, this is a question here. Actually, there was one more question. If you look at your own worksheet, you saw one more question, but we have already covered that the last time. Okay, look at this now. Okay, 2013, booklet B, question 42. What are they testing you on? I think all of you are very good at this. Okay, they are testing you on the characteristics or properties, right, of solid, liquid, and gas. Specifically, in this case, they are talking about air, right? So air is what they are focusing on. You need to know because air is a gas, right? So it does not have definite shape, it does not have definite volume, etc. How do you calculate this? What's the final volume? If I check your answers, I do check your answers, you know. So if you are doing your work, I will be looking at it also. Okay, and I know someone actually got this wrong. So let's take a look. Now, this Alex conducted an experiment using this setup. So he used this particular setup to conduct one experiment. He used the tap to remove 20 cm of water. So this 20 cm of water, initially at 150 cm, it is over here. So if 20 cm is removed, it will drop to this level. Okay, something like that. Go on. So after that, right? No problem. Janelle, are you okay now? I hope you're okay. Let me know. Can you tell me what happened? No worries. No worries. Okay. If you all have done it right, after this, you want to let me take a look at your answer, you can. Abram, that is the one that we have inside, right? Inside our tutorial. Okay. Janelle, you must take care. Promise me you take care of yourself. No problem, Chloe. I understand. So you see, once I have actually lesser water means what? Means more space, right? So these are just some of the pointers you must remind yourself. Lesser water means more space for air. Okay? How much more space? 20 cubic centimeters. So instead of 50, that will be 20 cubic centimeters more space. So now this has become only 130 cm of water, right? After that, so there is space now, okay? 20 added, that means 70 is available for air. Okay, now, if this guy, right, Alex, add in another 15 cubic centimeters, what will happen here? Rahar, be careful about this. So if I put in 15, okay, it is still going to stay at 70 cubic centimeters, right? If I add in 20 cubic centimeters of air into it, it is still going to stay at 70 cubic centimeters. Why is that so? Okay, so the final volume is going to be like this. Why? Because air has no definite volume. Okay, the volume of air, right? Take note, the volume is determined by what? Is determined by the space it occupies. Take note of this. Don't make the error again, all of you. Okay, so volume of air is actually determined by the space that it is occupying. So even if I want to take out 40 cubic centimeters of air, what is the volume of air inside this vessel, this container? It is still 70 cubic centimeters. Must know this. If you're okay, give me a thumbs up. Okay, very good. So if you're feeling sleepy, you know what you can do? You stand up, do star jump. Do 2 or 3 star jump. That's what I do, or that's what I did when I was a student to make myself wake up. Okay, if you sit down for too long, you will feel sleepy. Okay, so explanation, they actually do all this working for you, but I choose